Hello, welcome back to the Chemistry Made Simple podcast. I'm your host Matthew Macario, and this is episode 5. We're going to be talking about mass spectrometry. And what we're going to be talking about is what is mass spectrometry. We're going to define it. We're going to be talking about what a mass spectrometer is, and we're going to look at some of the question types that you're likely to face in an exam. So firstly, what is mass spectrometry and what does it do? Spectrometry is the measurement of the mass of atoms, molecules, fragments of molecules. At this level, when we're introducing mass spectrometry, we're just going to be looking at elemental samples, but that can still be molecules as well. Think of chlorine, for example, which exists as a molecule. Why do we need to measure the mass? Well, because we're measuring the mass of the isotopes, and we're also seeing what the relative abundance is, in other words, what proportion of an element's atoms are one isotope or another, and therefore we can work out the average atomic mass. So how do we do it? Well, we use a spectrometer, a mass spectrometer. That's the device which does the measurement. It's a device where we can put a sample into one end, and there's a detector at the far end, and some magic happens in the middle, which we'll talk about in a moment. And we obtain a spectrum that shows us the masses of what is present and also the relative abundance of what's present in the sample too. So what is that magic that goes on? Well, when the sample is injected into the instrument, it first enters the ionization chamber, and that ionizes the sample. So molecules of our sample lose electrons and become positive molecular ions. And some molecules are broken down into smaller fragments, such as individual atoms, and each of these also have electrons removed and become positive ions. These are then focused and accelerated into the flight tube, and they pass down the flight tube towards the detector. Now it's important to note that the flight tube has a vacuum pump attached, so there are no air molecules, for example, to interfere with the passage of our ions down towards the detector. Now at this point we need to differentiate between two different types of spectrometer. If you're taking the AQA syllabus, you'll be studying the time of flight mass spectrometer. And in the time of flight mass spectrometer, the flight chamber is straight, has a known exact length for the ions to pass to the detector. And the ions are given a particular kinetic energy when they're accelerated down the tube, and we measure the time taken for an ion to pass down the tube to the detector. Now, because the speed of the passing of an ion down the tube is relative to its mass, it is therefore possible to work out the mass of the ions that have passed down the tube, as well as their relative abundances. If you're studying a different syllabus of A level, or if you're taking advanced higher, then we'll be talking about the mass spectrometer that uses the magnetic deflection method. Now in this case the flight tube is not straight, it goes around a curve, and around that bend there is a powerful electromagnet. Again, the ions are accelerated down the tube with a particular kinetic energy, and there's a particular magnetic field applied. In this case we're not measuring the time that an ion takes to get to the detector, but we're measuring where on the detector the ion strikes, because going around that bend, ions of different mass will have their path deflected slightly differently and therefore hit the detector at a slightly different position. Don't forget to grab your download when you finish listening to the episode. It includes a diagram of each of the spectrometer types and a description of how each of them works. I'll give you a link at the end of the episode how to get that. Okay, so what type of questions will you face? And you may be asked for a basic description of how the spectrometer works, how it functions, and how it detects the mass of ions. Or to sketch and label a diagram of the spectrometer. There's a lot of mathematical questions, so you might be asked to calculate the relative abundance, relative atomic mass, or the mass of an individual isotope. And really, if you have an understanding of relative atomic mass, that is just a maths question. And we have a detailed walkthrough of this type of question in the chemistrymadesimple.net membership. If you're studying AQA, you might be asked to predict which is the slowest or the quickest ion to get to the detector from a particular sample. In that case, you just need to remember that the heavier ions move slightly more slowly. So the slowest ion is the ion from the isotope which is heaviest. And of course, the quickest ion is from the lightest isotope. You might be given a simple spectrum and be asked to spot the error. You may be asked to predict the spectrum for a particular element, in which case you need to just sketch your prediction. So let's consider an example of that. How about if the sample was chlorine? Chlorine exists as a Cl2 molecule, and chlorine atoms exist as two different isotopes, chlorine-35 and chlorine-37. That means the individual atoms, when ionized, would give us peaks at mass 35 and mass 37. And the chlorine molecule can exist in three different types. One where both chlorines are chlorine-35, one where both chlorine atoms are chlorine-37, and one where there is one chlorine-35 and one chlorine-37 atom. So there are three different possible ions from ionized molecules of chlorine. There would be one with a mass of 70, one with a mass of 72, and one with a mass of 74. And this is the sort of detail that would be expected in that kind of question. We'll be looking for peaks for the different individual isotopes and also peaks for the different mass variations of the molecule too. When you go on to consider the mass spectrum of compounds, which is usually organic compounds, you may be asked to consider the fragments of molecules. Also at that point, you'll find that the mass spectrum of a compound is often included in a larger analytical type question. And in that case, you'll use it to find the molecular peak and sometimes the fragments of molecules. And those are things that we'll discuss in a later episode. So what have we talked about today? We talked about mass spectrometry being the way that we measure the mass of atoms, isotopes, ions, how we work out relative atomic mass and often relative molecular mass. We've described a mass spectrometer as being a device which we're able to put a sample. The sample is ionized, passed down a flight tube through a vacuum, and a measurement is made based on the time it takes or the deflection caused by a magnetic field. And we've talked about the different question types that you might face or you're likely to face in an exam as well. So if you've got any more questions on this topic, let me know. Or if you have a suggestion for a question or topic that you'd like to see covered in an upcoming episode of the podcast, then get in touch. It's matthew@chemistrymadesimple.net, or contact me directly on Instagram. It's chemistrymadesimple. And to get your download from today's episode, visit chemistrymadesimple.net/mass. Put in your details and you'll get that download very soon. Now we're going to be back in 2 weeks' time with another episode, so look after yourselves till then, and I'll speak to you soon.